Let's start with the question itself. Look at the words. The most basic word here is before. When we use that word, we automatically make a hidden assumption. We assume time was already there, ticking away, ticking down the seconds, waiting for something to start. We assume a timeline that stretches backward, past the birth of the universe, into whatever existed first. That assumption feels unshakable. It matches every single experience we have ever had as human beings. Every event we have ever lived through came after something else, and before something else. Time is the background to everything. It never started. It just always was. But modern cosmology blows that assumption completely apart. Every single thing we interact with, everything we can see, measure, name, or test, space, time, matter, energy. Every single part of what makes our universe what it is burst into existence at one single event, the Big Bang. This means time itself did not exist before that moment. It started right along with the universe. If time started at the Big Bang, then asking what came before the universe is a lot like asking what's north of the North Pole. The question itself is built on a wrong assumption. There is no such place. There may be no such thing as before at all. Most people carry a very specific mental image of the Big Bang. It goes like this. There was already empty space, stretching out forever, completely dark, completely still. Then, one day, a tiny point of super-dense matter exploded outward. It blew shrapnel of matter and energy into that pre-existing empty space, and that explosion became the universe. That image makes sense to our brains, because it matches every explosion we have ever seen in our lives. A firework, a bomb, a volcanic eruption. All of these happen inside space. They expand into empty air that was already there. But that image is completely wrong. It misses the entire point of what the Big Bang actually was. This was not an explosion that happened inside empty space. Empty space did not exist before it. The Big Bang was an expansion of space itself. The entire fabric of the cosmos. Every inch of the distance between every 2 points in the universe burst outward from an infinitely dense, infinitely small starting point. That starting point was not sitting in empty space. It was all the space that ever existed, compressed down to zero volume. When the Big Bang happened, that compressed point of space stretched. It kept stretching. It is still stretching today, 13.8 billion years later. Every new cubic light year of space that we measure was created by that ongoing expansion, right from that original infinitely dense starting point. Let's go back to the North Pole analogy to break this down fully. Most people hear it and think it's just a clever word trick. It's not. It's a concrete example of how logic can break down when you ask a question that crosses a fundamental boundary. Stand at the North Pole right now. Every direction you face is south. There is no direction that is north. The word north describes a direction you move along the Earth's curved surface. It only has meaning between 2 points that are both on that surface. Once you hit the pole itself, the concept stops working. It does not mean we just haven't found the north point yet. It means the question itself is built on a wrong premise about what direction means. The same exact logic applies to time and the Big Bang. Before describes a position in time. It only has meaning for events that exist inside time after time itself began. Once you hit the starting point of time, the concept of before stops working. It does not mean we just haven't found the right event yet. It means the question relies on an assumption that time existed before time began. That is why asking what came before the universe might be just as meaningless as asking what is north of the North Pole. There may be no such thing as before at all, because time itself did not exist prior to the Big Bang. This is the official, consensus answer you will get from most modern cosmologists today. It checks out mathematically. It fits every observation we have made of the cosmic microwave background, the expansion rate of the universe, and the distribution of matter across the sky. The logic holds, but this answer has not satisfied everyone. It has not stopped generations of scientists and philosophers from digging for a real, concrete answer anyway. For human beings, this question is not just a word game. It is not just a trick of broken logic born from crossing a fundamental boundary. We want to know how we got here. We want to trace every line of cause and effect all the way back to the first cause. We cannot accept that there is a hard stop where the questions stop, no matter what the math says. Thinkers of every stripe have spent their entire careers pushing past this supposed boundary, testing every possible angle, looking for any crack in the logic that might let light in. Some start from the rules that govern the smallest parts of our universe. Some draw on patterns we have already observed in the expansion and contraction of cosmic systems. Some reach for entirely new frameworks of space and time that rewrite everything we thought we knew. To understand this idea, we first have to let go of everything our intuition tells us about what nothing actually means. In everyday life, nothing means empty space. It means a void with no matter, no energy, no objects of any kind. We assume that if you remove every last particle from a room, you are left with pure, inert nothingness. That assumption works fine for the scales we interact with every day. But when you shrink down to the smallest scales that physics can measure, everything changes. At the quantum level, the vacuum that we call empty space is not empty at all. It is a restless, constantly shifting energy field that never truly rests. Every point in this field flickers with random fluctuations. Tiny, temporary particles can pop into existence out of nowhere, entirely spontaneously, with no pre-existing cause. These particles do not stick around. They vanish again just as quickly as they appeared, leaving no trace behind except for the tiny energy shift that created them. This is not just a wild thought experiment. It has been tested repeatedly in laboratory experiments. We can measure the effect of these spontaneously appearing particles on the energy levels of atoms. We can see the force they exert between two parallel metal plates in a vacuum. The effect is small, but it is measurable, and it matches the predictions of quantum physics exactly. So in quantum physics, nothing is not the end of the story. It is already a dynamic, active system that can generate real, physical phenomena completely out of its own internal fluctuations. If the quantum vacuum can spontaneously generate tiny particles with no pre-existing cause, it follows that the same rules could apply on a far grander scale. That is the core logic of the hypothesis that a growing number of leading physicists have built over the last half-century. Every fluctuation in the quantum vacuum has a random size and energy. Most are tiny. They produce particles that vanish in a fraction of a second. They never grow beyond that tiny, temporary blip. But randomness means rare things happen. Given enough time or enough space for fluctuations to occur, you will eventually get a fluctuation big enough to change everything. A fluctuation with enough concentrated energy to trigger a burst of expansion that does not stop until it has stretched into an entire universe. This is not a guess pulled from thin air. It follows directly from the same quantum rules we have already tested in the lab. If small particles can pop into existence spontaneously, a whole universe can do the same thing. The math checks out. It fits the same observations that support the Big Bang as the starting point of our observable space and time. In this framework, our entire universe is nothing more than a giant, extremely rare cosmic accident. It emerged from the quantum vacuum with no pre-existing cause. There is no before to speak of, no creator, no intentional trigger. It just began. It expanded. It cooled. It formed stars and galaxies and planets, and eventually, life that could look up at the sky and ask where it all came from. This idea answers the question of origin without adding any new, untested assumptions beyond the quantum rules we already know work. It does not require anything to exist before the Big Bang. It does not require a first cause. It just requires one extremely lucky random fluctuation. This quantum accident hypothesis is elegant. It fits existing observations, and it requires no new, unproven physics. But it is not the only major idea that has gained traction among cosmologists over the last century. There is another, far older framework of thinking that has been revised and updated for modern physics, and it completely rewrites the story of what came before. The core problem that this competing theory tackles is the same one that haunts every origin story that starts with a single Big Bang. How do you get something from nothing, even if quantum mechanics allows for spontaneous fluctuations? The cyclic universe theory answers this question by rejecting the entire premise of a single beginning. It does not start from nothing, because there was never nothing. It proposes a simple, repeating mechanism that has gone on forever, and will go on forever. Here is how it works. Our current universe started with the Big Bang, and it has been expanding outward ever since. We have measured this expansion. We know it is happening. But what if that expansion does not go on forever? What if, over billions and billions of years, the expansion slows down, stops, and reverses? Gravity pulls every galaxy, every star, every particle back toward each other, faster and faster, until everything collapses back into the same infinitely dense point that our Big Bang exploded out of. This final collapse is called the Big Crunch. When that collapse hits its peak density, the energy rebounds. It explodes outward again in a new Big Bang, creating a new universe with its own expansion, its own stars, its own galaxies, and its own timeline. The whole process repeats. Expand for billions of years. Slow. Stop. Collapse. Rebound. Bang. A new universe is born, and the old one is gone. It is a never-ending loop, turning creation and destruction into a constant, eternal cycle. The never-ending cycle of Big Bangs and Big Crunches rewrites every assumption we have about the start of everything. It does away with the need for a single, spontaneous accident out of the quantum vacuum. It answers the original question with a clear, direct statement that upends all prior thinking. In this model, something definitely existed before our universe. Not an empty quantum field, not a vague, unmeasurable void. A full, complete, older universe that expanded, formed stars, grew cold, and collapsed back down to the dense point that birthed us. And that older universe did not come from nothing, either. Before it existed, there was another one. An older universe that went through the exact same cycle. Expansion, slowdown, collapse, rebound, new birth. And before that universe, another one. And another. And another. The chain stretches backward forever, with no break, no starting point, no first universe that needed to pop into existence from nothing. Many people push back on this idea instinctively. They ask, if every universe needs a prior universe to create it, where did the whole chain start? But that objection misses the core of the cyclic model. The model does not need a starting point. It does not require a first cause. The cycle has always been running. An infinite number of universes have already existed before ours, each one born from the collapse of the one that came before it. Each one has its own history, its own stars, its own galaxies, possibly its own forms of matter and energy that we can never observe, because they were erased when their universe collapsed. This framework eliminates the paradox of getting something from nothing entirely. Every universe comes from the collapse of the one before it. There has never been a point where nothing existed. There has never been a first Big Bang. The cycle is eternal. It always has been, and it always will be. The cyclic universe model solves the paradox of something from nothing by stretching origins backward into an infinite past. It does not require a first cause, because there was never a first event. But even with this elegant solution, modern physics has pushed the question even further into territory that stretches the human imagination past its breaking point. This next concept is widely considered the most mind-bending idea that serious physicists have ever put forward for public consideration. It does not challenge the Big Bang, does not reject quantum fluctuations, and does not require an eternal cycle of collapse and rebirth. Instead, it rewrites the entire map of what reality actually is. What if our Big Bang was not the only origin event that ever happened? What if our entire universe is not the whole of reality, just a small, isolated piece of it? That is the core claim of multiverse theory. To understand how this works, you have to set aside every assumption you have about what space and reality actually are. We have always thought of space as something that exists inside our universe, something that expanded out of the Big Bang 13.8 billion years ago. But multiverse theory flips that idea on its head. It proposes that our universe is contained within something far larger, something that existed long before our Big Bang ever happened. That larger reality is a vast, unobservable sea of empty space that our universe cannot reach, cannot interact with, and cannot measure. Inside this vast sea, countless individual universes float like separate bubbles. Each bubble forms when a region of space inflates into a separate, self-contained universe. Our own universe is just one of these bubbles. It is tiny, it is isolated, it is cut off from every other bubble universe out there in the vast sea. And the number of these other bubble universes is not just large, it is countless. Countless separate universes, all existing alongside ours, all floating in that same unobservable sea. Each of these bubble universes did not just form in isolation from ours. They also evolved with their own unique set of physical laws, constants, and forces that govern everything that happens inside them. The specific combinations of these rules that we see in our universe are not universal. They are just the random set that locked into place when our particular bubble inflated out of the larger sea. Change a single constant even slightly, and everything changes. If the force of gravity was just a little stronger in a bubble universe, stars would collapse into black holes before they could ever fuse enough hydrogen to produce the elements for life. If the strong nuclear force was just a little weaker, atomic nuclei could never hold together at all. No atoms, no molecules, no stars, no life. Nothing like the reality we know could ever form. Some bubble universes might look almost identical to ours, with only one tiny change that alters the entire course of history. Some might have only 3 dimensions of space in total, or 10, or 20. None of them anything like the 3 we move through every day. Each one has its own separate timeline, its own process of expansion and evolution, its own completely distinct version of what reality can be. None of these universes depend on the one that came before it, the way they do in the cyclic model. They do not form one after another in a single chain stretching backward through time. Instead, every single one of these bubble universes exists right now, all at the same time, all floating in that same vast, unobservable sea of the larger multiverse. The entire original question of what existed before our universe is built on one unshakable, unspoken assumption that we never even think to question. That assumption is simple. Time moves in one direction. There is a past, there is a present, there is a future. Everything that exists has a place in a single, straight line that we can trace backward, step by step, all the way to the start. The cyclic universe model plays by these rules. It just stretches the line infinitely far backward. The quantum vacuum accident model also plays by these rules. It just cuts the line off at the first moment of our Big Bang, with no line that comes before. But the multiverse model throws this entire set of rules out the window. There is no single line. There is no shared timeline that connects every universe in the multiverse into one ordered sequence. Every bubble universe has its own separate timeline, entirely independent of every other. These timelines do not line up. They do not follow one after another. They do not connect at all. In most cases, because the bubbles themselves are completely cut off from interaction. Our timeline starts 13.8 billion years ago with our Big Bang. Another bubble's timeline might have started 30 billion years before ours. Another might start 100 trillion years from now. All of these timelines exist at the same time, in the same larger multiverse. When you stack all these independent timelines on top of each other, all existing simultaneously, the word before loses any coherent meaning. There is no universal clock you can check to say this universe existed before that one. There is no single sequence you can trace backward to find the very first thing that ever happened. The concept of order itself dissolves. What looks like a clear, logical question to us, born of how we experience time in our own bubble, becomes a question that cannot be answered because it relies on a structure of reality that does not actually exist. Let's push that deconstruction even deeper, all the way to the very thing that gave us the concept of before in the first place: time itself. Some of the world's leading theoretical physicists have spent decades building toward a radical, mind-bending conclusion. Time, they argue, is not a fundamental feature of reality. It is an illusion. It is a construct our human brains have evolved to build, to help us make sense of the raw, unordered information we take in from the world around us. At the most fundamental, underlying level of reality, the level we cannot access with our limited senses and evolved intuition, there is no such thing as past, present, or future. There is no flow of time that carries us from one moment to the next. Everything that ever happened in the entire history of our universe, everything that will ever happen, from this second all the way to the final heat death or collapse of everything we know, all of it simply exists, all at once. It forms a single, static, timeless structure. There is no past moment that has vanished into the rearview mirror we call memory. There is no future moment that is waiting for us to arrive and bring it into existence. Every point in what we call our timeline is just as real as the moment you are experiencing right now. The Big Bang that started our universe 13.8 billion years ago still exists right now in this fundamental structure. The final heat death of our universe, trillions of years from now, exists right now too. We do not see it this way because our brains are built to process reality in sequence, one moment after another, to survive in the macroscopic world we live in. But that sequential processing is not a reflection of what reality actually is. It is just a map our brain draws. The same way a two-dimensional paper map of the world represents a three-dimensional sphere. The map is useful for getting around, but it is not the actual territory. If this model of reality is correct, then we have gone past the point of just saying we cannot answer the original question. We now have to say something much more radical. The question itself is wrong. It is built entirely on the illusion our own brains create. Let's trace that logic step by step. The question is, what existed before the universe? The word before is the first word that gives the game away. Before is a relational term that only makes sense in the context of sequential time. It describes a position on the linear timeline our brains construct for us. Before only means something if there is an ordered sequence of moments, one coming after another, with earlier moments that can exist prior to later ones. If there is no such thing as sequential time at the fundamental level of reality, if every moment that ever was or will be exists right now all at once, then the entire concept of before ceases to have any meaning at the most basic level of the universe. It is not that the answer is hidden from us. It is not that we just have not found the right evidence yet to figure it out. The question does not connect to reality at all. It is a question that only exists because of the map our brains draw. When you ask what existed before the universe, you are asking a question about the map, not the actual territory. The territory has no before. It has no sequence. It has no ordered line of moments that you can trace backward from where we stand now. There is no starting point that sits earlier in a sequence than all the other moments. The entire framing of the question relies on a feature of human perception, not a feature of the reality we are trying to ask about. That is what makes it the wrong question entirely. You cannot get a meaningful answer to a question that only makes sense inside an illusion. This does not mean the Big Bang is not a real feature of our universe. It does not mean everything we have learned from 100 years of cosmology is just another illusion, built on top of the illusion of time. The Big Bang is still a real thing. It is still the event that connects every particle in our observable universe to a single common point, 13.8 billion years back along our human timeline. What changes is how we understand what that point actually is. From our limited perspective, trapped inside the sequential map our brains draw, that point looks like a beginning. It looks like the first moment in a line that stretches forward to right now and on into the future. It looks like the start of everything, the point before which there was nothing. But from the perspective of the actual timeless territory of ultimate reality, that point is not a beginning at all. It is just a boundary. It is an edge of the static structure we exist inside. That edge cuts off the part of the structure we can access through our sequential timeline. There is nothing on the other side of that edge that sits before our universe, because the concept of before does not extend across that boundary. The boundary itself is the point where the linear timeline we experience comes to an end when we trace it backward. That does not mean there is nothing beyond it in the timeless structure. It does not mean that nothing existed beyond it. It just means that the ordered sequence our brains rely on stops working right there. We can keep tracing the idea of before past that edge, but we are still tracing lines on the map. The territory does not have lines there. It just has a boundary, and a structure that does not require a start to exist. The Big Bang is the start of the story we tell ourselves to make sense of our place in the universe. It is not the start of the universe itself. This line of reasoning strips away one layer of assumptions after another, reframing the question we started with until it dissolves entirely. But it does not leave us with a closed, finished answer. It leaves us standing at the edge of a far more open, far more unsettling question that we cannot dissolve just by pointing out flaws in our own perception. Let's trace the logic that leads here, step by step. We have already established that the universe could have popped into existence out of a quantum vacuum, no pre-existing cause required. We have established that it might not need a before at all, that it could exist as part of a static, timeless structure with no true starting point. All of these models accept one basic given. The universe exists. We are here. It is here. Something is here. But none of these models answer the next question that naturally rises up out of that acceptance. If the universe does not need a pre-existing cause to begin, if it can simply appear out of the quantum void without any force or reason pushing it into existence, then why does anything exist at all? Why is there something, rather than just nothing, stretching back forever and continuing forever? This is not a question about where our universe came from. It is not a question about what came before the beginning we observe. It is a question about the most fundamental fact of all, that there is anything at all. Right now, we do not have an answer to this question. Not even a partial, work-in-progress answer that aligns with everything we already observe about the universe. We have speculation. We have philosophical arguments that go back thousands of years, stretching all the way to the earliest recorded thinkers who first stared at the sky and asked why the sky was there at all. We have thought experiments that twist our brains into knots trying to unpack the difference between something and nothing. But that is not the same as a testable scientific hypothesis. In physics and cosmology, an idea is only useful if we can test it. It has to make a specific prediction about something we can measure, something we can observe either through a telescope, a particle accelerator, or a detailed mapping of the cosmic microwave background radiation left over from the Big Bang. If the idea makes a prediction, we can go out and check if that prediction matches what we actually see in the real world. If it matches, we hold on to it and keep testing it. If it does not match, we discard it and start over. That is the process that got us to the current models we rely on today. The Big Bang, quantum fluctuations, the expanding universe. Every step of that process required testable predictions that held up under scrutiny. This question, though, does not yet have that. No leading theory of cosmology, quantum physics, or multiverse structure has produced a prediction we can actually test to answer why there is something rather than nothing. We can map how the universe expanded. We can trace it back to the boundary of the Big Bang. We can describe what that boundary looks like from our perspective. We can speculate about quantum vacuums and cyclic universes and static timeless structures. But none of that gives us a way to test why existence itself is here, instead of no existence at all. Right now, that answer stays out of reach. It is not even on the horizon of testable science. This lack of a testable answer does not mean the question is unanswerable forever. It does not mean we will never find a way to frame it in terms that fit the rigorous demands of scientific inquiry. It just means we are stuck right now. Stuck between the question we can clearly ask and the answer we cannot yet reach. When we hit a wall like this in scientific inquiry, the first thing we do is step back and check our assumptions. We check the direction we are looking, the path we are following, to see if we have been walking toward the wrong edge of the map this whole time. That is exactly what is happening here. For centuries, we have approached the question of what existed before the universe by looking backward. We trace our current universe back through expansion, back through the Big Bang, back through whatever came before the Big Bang. Always backward, always deeper into the past. That instinct makes sense. It fits the way our brains experience time. We move forward through time, so we assume the beginning of everything must lie behind us, in the direction we have already come from. We assume the answer has been there all along, waiting for us to trace our steps back far enough to find it. But what if that entire assumption is wrong? What if we have been looking for the answer in the wrong place all along? We have spent all this time staring backward, digging into the moments before the Big Bang, searching for a cause that lives in the past we can no longer observe. But what if the answer was never there to begin with? What if the answer does not lie behind us, back before the universe ever began? What if it lies ahead of us, out in the vast, unexplored edges of physics that we have not even begun to map and test? Every major breakthrough in the history of physics started this way. The answer sat out on the unexplored edges of what we could measure, what we could imagine, waiting for someone to push past the limits of what we already knew to reach it. Newton did not find gravity in the distant past of human thinking. He pulled it from the unexplored future of what we could understand, and rewrote our entire model of how the universe works. Einstein did not dig up relativity by tracing existing ideas back to their starting point. He reached past the assumptions that had held physics back for centuries, into the unexplored space ahead of what anyone had ever thought before. That same process is still happening today. Every year, we build larger telescopes. We build more powerful particle accelerators. We map more of the cosmic background. We test more of the strange rules that govern the quantum world. We push step by step into those unexplored edges, each generation moving a little further than the last. The answer is there. It is waiting. It will not stay out of reach forever, not if we keep walking toward it. One day, someone will reach it. All we have to do is keep looking ahead.